Welcome to VLSI design flow video. From today we will be looking at unit flow, that is floor planning and placement. This unit also consists of 6 video lectures. The contents of this unit are clock skew, clock distribution techniques, clock jitter, supply and ground bounds, power distribution techniques, power optimization, interconnect routing techniques, wire parasitic, signal integrity issues, I/O architecture and pad design. The objective of this course is to make you understand the physical design of the chip. After watching all the 6 video lectures, you will be able to demonstrate an understanding of working principles of clocking, power reduction and distribution. First, we'll be looking into the floor planning and placement basics. So in that, first let's see physical design overall flow. This is the back-end flow. The front-end flow I have already discussed in the first unit. So here comes the main part is how to implement on the chip the design what you have done or the blocks what I have designed. So for that the first step is to partition. So partitioning is the first step. The area or the chip area what we have has to be partitioned. Next comes the floor planning. Floor planning is a must so that where to place and which block to place, whether that place is suitable or not in that particular area will be done in the floor planning. Once the floor planning is done, then comes the part as placement, placing of these blocks. So before placing of these blocks, the cost estimation is must so that we can make some improvement in the placements. Then comes the routing region definition, where the routing is a must for the clock lines and the supply lines. We are supposed to route them, and the connection of the blocks also is done using the routing. So this has to be defined. And then comes the global routing. Global routing is the overall connectivity as a global connection. Here also we need to estimate the clock. For that, if we need the improvement, then we can make changes in the global routing. And then comes the detailed routing. Detailed routing is every block, every step or every design or the every element what we place on it has to be made connections to see that all these connections are established. So that is called as detailed routing. Even for that, cost estimation has to be done so that improvements can be done. Then compaction and cleanup, and then we need to place the wire layout database so that all these things will be established on the chip. So this is what the physical design overall flow. Quickly moving on to the floor planning basics. So in this unit you will be looking at the floor planning and placement basics. So as you see in the diagram on the right hand side, floor planning is nothing but a plan a house floor planning is. So here you can see the blocks are like in the house what we do. Here should be our living room, here should be our study room and so on. We just plan and we see that the area what we have is to be completely utilized. So find approximate locations of a set of modules that need to be placed on layout surface. Available region typically considered as rectangular generally, but modules are typically general, but they may not be general in shape, rectangular in shape, but they can be even L shape sometimes. So that also has to be considered when we look into the floor planning. Next we look at floor plan terminology. Some of the terms are to be kept in mind, like this is the corner cell, and these are the I/O cell or the I/O pad for giving the input and output blocks. Next, this is the bond pad, bonded, that means fixed for some particular task. And the thick black line what you see here is the input output power ring. For input output lines also we need some power supply. So they are input output power ring, and the thick red line inside one, what you see is the core powering. For the core, the actual core what we have inside it, for that the power which is needed is given as a ring, that is the core power ring. And then this is the hard macro block, which can be a RAM or ROM or PLL. And the other core what you can place is kept here, that is the core area, and this is the scribe line. So goals of the floor plan are, we need to set up some goals, right? So they are: partition the design into function blocks, arrange the blocks on a chip. We need to arrange properly. First we need to partition, as you have seen in the physical process. Then arrange the blocks properly on the chip. Then place the macros. Macros are the main blocks. Then dedicate the location of the IO pads. Decide and dedicate them. Some are the dedicated, which are called as bonded, and some are simply generally used as IO. So decide the location of the IO pads. Decide the location and number of power pads we need, and decide the type of power distribution what we are supposed to use or we are going to implement. All these things in detail we'll be looking in the coming lectures. Next, what are the floor plan inputs? Floor plan inputs are a synthesis list. They can be from physical libraries. They can be from logic libraries. They can be from timing constraints. They can be from power requirement, floor planning control parameters. So let's see in detail each and every one. So a synthesis, first we'll see the synthesis list. A netlist is a description of connectivity of an electronic circuit. In its simplest form, a netlist consists of a list of electronic components in a circuit and a list of the nodes they are connected to. It can be in the form of Verilog or VHDL. This netlist is produced during logical synthesis, which takes place prior to the physical design stage. So netlist, for example, I can give you, like it is generated in the logical synthesis part. So suppose if I design a XOR gate, if the synthesis tool says that there is only a need of one logic gate, that too it is an XOR gate with 2 input nodes and 1 output node. Okay, that means how many elements here are noted down, or the list is how much? The list are 2 input nodes, 1 output node and 1 logic component. That means in the list I can see only 3. But if the synthesis tool generates in the other way, saying that it needs 2 AND gate, 1 OR gate, 2 inverters, 2 input nodes and 1 output node. Getting with me? That is due to the expression what I use or how I define in the HDL. The Verilog HDL, if I define it in some of the ways, the synthesis tool will generate based on the design what you have done in the Verilog or VHDL code. So here in the second part what I am saying is it is A bar B plus AB bar. So when I say A bar B plus AB bar, that function when it has to be implemented, it needs 2 AND gate, 2 inverters, 1 OR gate and 2 input nodes and 1 output node. So here the list is now increased. The list is now increased to 5. Initially what I said is the list is consisting of only 3 elements. Now the list is consisting of 5 elements. So likewise, the list based on the design what you have done will be generated by the synthesis tool. Next is the physical library. Physical or reference libraries contain physical information of standard, macro and pad cells, which is necessary for placement and routing. So these libraries define placement file like height of the placement house, minimum width, resolution, preferred routing direction, pitch of routing tracks and so on. So the next one can be from the logical libraries. This library file which provides timing and functionality information and each and every standard cells used in the design. It also provides timing information of hard macros such as IP, ROM, RAM, etc. The other inputs are timing constraints. The timing constraints can be SDC constraints, clock constraints, max Q, max and minimum insertion delay, number of clock domains, clock start points, etc. And it may also need the power timing constraints like for power requirement, power and ground nets, floor planning control parameters like die size estimation, core size, aspect ratio, core height, and core width. What are the problems related to floor planning? Till now we have seen what are the inputs for floor planning. Now what are the problems with floor planning? The floor planning problem is to plan the positions and shapes of the modules at the beginning of the design cycle to optimize the performance of the circuit. How can you optimize? By planning proper positions and shapes of the modules at the beginning of the design cycle itself. But still, there can come up like the chip area, total wire length, delay of the critical parts, routability, and the other things like noise, heat dissipation can also result in the performance of the circuit. So if these things are also now optimized, then we can say that the circuit performance can be optimized even though we plan the positions and shapes. If the chip area is less and the design what I'm going to plan on the area what I have is more, then it becomes again a problem. And if the wire length is small or too long, then also there can be a delay. If there are some critical parts, that also may result in delay. And the routing, that means the connections, if they are not proper, then that also will result in the performance of circuit. So likewise, we need to see these parameters to optimize the performance of the circuit. In floor planning, several alternatives for each block are considered. They are to be considered, without which we cannot make it perfect. Challenges. What are the challenges in floor plan? The challenges are, as I said, chip area or the die area, congestion, timing, power network design, electro migration, IR drop. So what are these? Die area is the chip area. Congestion is more and more thing if we are trying to put in the same area, then it becomes a congestion. And timing is the main constraint where we need to see the timing distribution or the clock distribution, and the power network design, that means the power distribution, that we'll be seeing in the coming lectures. Then the electro migration and the IR drop, that these two are result of the wiring. If the wire has some resistance and the capacitance on the inductance, then these may result in the electro migration and IR drop. So we need to see all these parameters. We need to look into all this. Next, what is floor planning versus placement? Both will determine the block positions to optimize the circuit performance. But floor planning is like details like shapes of blocks, pin assignments, etc. are not yet fixed in the floor planning. We are just planning. They are not yet fixed. Blocks with flexible shape they are called as soft blocks because we can shift here and there. But when we come into the placement concept, the details like module shapes and IO pin positions are fixed because we have placed. They are fixed. So those blocks, they are called as hard blocks. The point to note are floor planning problem is more difficult to handle as compared to placement. Multiple choice for the shape of a block. In some of the VLSI design styles, the two problems are identical. So these are some of the points which you are supposed to remember. Thank you for watching.